Hello everyone. In this video, we will discuss regarding with motion. So before going to learn actual definition of the motion or bookish definition of the motion, let us try to understand the motion, the concept of the motion through some live examples. So what are those examples? Flying bird in the air, or the fish swimming in the water, or the blood flows through our veins and arteries, or the car moving on the road. All these are the examples of the motion. Atoms and molecules, their motion, motion of the planets, motion of the stars, motion of the galaxies. These are also examples of the motion. Motion of air by observing movement of the dust particles. Sometimes it happens like at home, through some windows or through some corners. Sunrays will come inside the room. And in those sunrays, we will observe these dust particles. We will observe these dust particles and movement of those dust particles. So with that movement or with that realization, we come to know that yes, there is some motion of the air in the room. Sometimes movement of the leaves and branches of the trees we will observe. Whenever it is about to rain, the leaves on the ground floor, they will start flying. Or the coconut trees, along with its leaves and the branches of the trees, this coconut tree, they will start moving or they will start to shake. We will observe the movement there. Or phenomenon of sunrise, phenomenon of sunset, and changing of the seasons. All these are the beautiful examples of the motion. So in coming videos, we will discuss actually what this motion is, what are different types of motion, how we define the motion, how we describe the motion. So all these concepts we will discuss in the coming videos. Thank you. Hello everyone. In last video we have discussed about different examples of the motion. In this video we will discuss about describing the motion. How we describe the motion. To describe the location of an object by specifying a reference point or the origin. Mainly, to describe location of a particular object, we need some reference point or the origin. With reference to this point or with reference to this reference point or the origin, we will locate that object or we can tell the location of the object. Now the question is how to choose this reference point. Answer to this is, for choosing this reference point, you can go with your convenience. According to your convenience, you can choose the reference point. Let us take an example. School in a village is 2 kilometers north of the railway station, and we want to describe this. So for this, the railway station is the reference point or the origin we have taken. We want to define the location of the school or location of this object with reference to this railway station. Here, railway station is the reference or the origin point. Now we know the directions: east, west, northeast, east, west, north, south, northeast, northwest, southwest, southeast. All these directions we know. We will make use of these directions. Now suppose this is the railway station. This is our reference point of the origin, right? And with reference to this railway station or with reference to this origin, we want to define the school. So this is the school, location of the school, and we know that that school is 2 kilometers north of the railway station. So north direction. So this is the north direction. So this is the north direction. In the north direction, so this is the north direction, 2 kilometers, the school is located. So here simply the railway station is here. In the north direction, 2 kilometer distance, school is located. Here, school, we have taken it as an object, and a railway station it as a reference point. Right. So this is the very simple or basic diagram I have shown. But with this basic understanding, in coming videos or in coming concepts, we will define the motion of the object. It may be for some uniform motions, non-uniform motions. There are also some graphs we will plot. So for basic understanding how we describe the motion, this is a very good example. So in coming videos, we will discuss more about how to describe the motion and how to define the motions. Thank you. Hello everyone. In earlier videos, we have discussed about different examples of the motion and how to describe the motion. In this video, we will discuss about different types of the motion. So there are four types basically we will consider. First is straight line motion. As you can see in this picture. So this girl, she is walking on this rope and she is walking in a straight path. She is supposed to walk on that rope in a straight path. And for walking, she is using this wooden stick to balance her weight. She has to travel in a straight path. If she don't follow that straight path, she will fall down. So in real life conditions also, sometimes few objects they have to travel, they must travel in the straight line path. Deviation from that straight line path is not allowed for that objects. Second is a circular motion. As you can see, this boy, he is rotating the spherical ball using this string. By making of this string, he is rotating the spherical ball. He is making one circular orbit around himself. There is one axis I have shown here. So around this axis or around himself, he is creating this circular orbit. He will rotate it. He will rotate that ball. He will rotate in one particular position. He will throw the ball. So this is one wonderful example of a circular motion. Another type of the example is rotate or rotating motion. So this is one table fan. So in this table fan, there are three blades. The three blades which are mounted on shaft. And as the shaft will rotate, these three blades along with that shaft, they will rotate and wind will come out of the fan. So this is one kind of a rotating motion where these blades will rotate along with the rotating that shaft. One more motion is vibrate or vibrational motion or vibration. The swing machine, we know everyone, the needle of the swing machine, it moves up and down, and this up and down motion will be in a continuous manner. So continuously this up and down motion is an example of a vibration. This is also one kind of a motion. And the last type is combination of all above motions. So whatever the straight line motion, circular motion, rotating motion and vibration, what we have discussed through some examples. So combinations of all those motions, it is possible for particular object, and combining all the straight line, circular, rotating, vibrational motion is also one kind of motion. Rather than this, one more type, two more types actually, uniform motion and non-uniform motion. So what is this uniform motion and non-uniform motion? We will discuss in the coming videos. Thank you. Hello everyone. In this video, we will discuss about object. What is object? An object may be appear to be moving for one person and stationary for some other person. There is one object. That object, I feel it is moving, but the same object, some different person sees, he feels that object is stationary. Object is the common, object is the same, but the perspective looking towards the object is different for the different persons or different peoples. There are basically two types of objects we can say, object at rest and object in a motion. First, let's study what is object at rest. For the object at rest, position of that object does not change with respect to time. Irrespective of the time, object position remains the same. Suppose this football, it is on the ground, and morning 10 a.m. I have seen the position, location of that. Now I know the position where it is located, how it is located, that I know. Now again after 1 hour, I have seen that ball. I came to know that still it is at the same position, it is at the same location, it is not moved at all, still it is stationary. Again after 1 hour, I have seen still the same. The position of the ball is not changed at all, even though time has increased. So whenever such condition happens, when the object position is not changes with respect to time, then we can say that object is at a rest or object is stationary. So this is one type of object I will say. Second is object in motion. Whenever the position now changes with respect to time, then we will say that object is in motion. So as you can see in this picture, this spherical ball is there, the spring is there, it is attached to the spring, this ball. Now if I pull this spherical ball, and if I release it, then this ball will go and it will impact on this ball on this ball on this ball on this ball on this. Then this ball will move to the right side, and again it will come back, again it will hit to this ball, again to this ball, this ball, this ball. So like that, that continuous motion will go on. Now in this case, if I consider this as an object, the spherical ball as an object, now the position of this spherical ball or all other these spherical balls, their position is changing with respect to time. So now I can say these balls are either moving or those balls are in motion condition. Right? So whenever the position changes with respect to time, that object will be in motion or the object is moving. Whenever the position does not change, we will say that object is stationary or object at rest. And whenever the position changes with respect to time, we will say the object is in motion or object is moving. Thank you. Hello everyone. In this video, we will discuss about object. An object may appear to be moving for one person and stationary for the some other person. There is one object, one person looking at the object, he feels that object is moving. And for the same object, but different person, if looking at it, he feels that object is stationary. Object is common, but the perspective towards looking that object is different for the different persons, different peoples. Let us take an example. For the passengers in the moving bus, the roadside trees appear to be moving backwards. Suppose you are traveling through a bus, you are this person, and if you are looking outside the window, you feel like these trees, the persons on the roadside, the cars, all are moving backwards. Like that feeling you will have. Opposite to this or contrary to this, person standing on the roadside perceives the bus along with the passengers is moving. Suppose there is one person who who is outside this bus or standing on the roadside, he perceives or he feels like the passenger along with this bus, they are moving. For us, this person is moving, but for him, this bus and the passengers are moving. And totally opposite to this, however, the passenger inside the bus sees his fellow passengers to be at rest. But suppose you are here and the person in front of you or beside you, you both people have feeling that we both are stationary. We are not moving. But actually with bus you are moving. So the passengers inside the bus or the fellow passengers with us, they have the feeling that we all are at a rest condition. So from this example, what we can feel or what understanding we have, what conclusion we have, that there is one object, but the perspective towards looking that object of different persons with different opinions. So how these things are helpful in terms of a motion, that we will study in coming videos. Thank you. Hello everyone. In this video, we will discuss about the scalar quantity and vector quantity and what is basic difference between the scalar quantity and vector quantity. For scalar quantity, magnitude is required. We have to give information regarding magnitude of that quantity. And second, there is no need to give information about direction. No direction required. Scalar quantity, there is only importance to the magnitude. There is no importance to the direction. Few examples of scalar quantity: mass, volume, length, time, distance, speed, work, energy, power. As you can see in this picture, suppose this car, it has a certain speed. When I'm talking about the speed, there is no it is not required to talk about with which direction the speed is. About this apple also, I have to give information about just the mass or the volume of the liquid inside this beaker or about the time. All these are the scalars quantity. Here magnitude has the importance. No direction is required to give information about these quantities. What about the vector quantity? Magnitude is required as well as directions are also required. Example of this is force, velocity, acceleration and moment. As you can see in this picture, now if I am talking about the velocity of the car, I have to give information about in which direction the velocity is. Or about this apple also, if I am keeping this apple on a weighing machine, I have to say like this apple weight is going downward direction. Or about this block which is on an inclined plane, and different arrows we have shown, this side, this side, this side. So every arrow will have some meaning, frictional force, weight. So for all those forces I have to give information about the direction in which they are moving. Or a simple example of scalar quantity what I can give, suppose someone asks you about your weight, what answer we will give? My weight is 50 kg or my weight is 40 kg. Whether we will answer like this, if I head towards west, my weight is 40 kg. If it is towards east, it is 42 kg. If it is towards north, it is 42.5 kg. Is it like that? No. What we will answer? We will answer only my weight is 40 kg or 50 kg. There no, it is not required to give information about direction. Simple example about vector quantity is if someone tells you open the door and come inside. So first thing what we will see that is there anything written on the door, whether it is written pull or push. We will check. If it is pull, we will pull it, and if it's push, we will push it. Right. So just because of those two words, pull and push, we will come to know about the direction. In which direction, if I go, I can open the door. So through that direction you will understood, or because of that pull and push word, you will understood about, you will get information about the direction. So there I need to give information about magnitude also and direction also. Such kind of quantities we will say vector quantities. Scalar quantity and vector quantity, they are very important for the physics point of view. In coming videos and for the coming concepts, we will make use of this scalar quantity and vector quantity in more depth. Thank you. Hello everyone. Last video we have discussed about different types of motion like circular motion, straight line motion, rotary motion and vibrational motion. So in this video we will discuss about one of the simplest motion, that is straight line motion. Let us consider this graph or one picture. What it indicates, the object has traveled along a straight line. This is a straight line path, and on this straight line path, when it has traveled, O is the initial position, or O is the reference point, or O is the origin where the object has started the journey, and A, B, and C are the corresponding positions of that object at the different instants. C represents 25 kilometer, B represents 35 kilometer, and A represents the 60 kilometer. In terms of motion along straight line, there are two very important terms, distance and displacement. They are used to describe the overall motion of the object and to locate its final position with respect to initial position at a given time. In a certain duration of a time when object travels, distance and displacement, these are two terms which will help to describe the overall motion of the object, mainly distance and displacement. How we are going to make use of it is we will focus on initial position and final position. Final position with respect to the initial position in a particular time interval. How it is, where it is, those kind of questions we will answer using the distance and displacement term. The important thing is we are locating the final position of the object with respect to the initial position in certain time interval. So as I said, distance and displacement, these are very important terms. We will discuss them in details. First, distance. What is distance? Distance is total path length. We will measure only the path length. We are not bothered about directions, or we are not considering any sign convention. We will simply measure the path length. Let us take an example. So in this uh, graph where the object has traveled along a straight line, during the motion from O to A and back to B, from A again it has came back to B, distance covered is. So as I said, the distance means total path length. Simply O to A, what is the path length? 60 kilometer. And from A to B, see, even though while traveling from O to A, with respect to initial position O, it is going in a right hand side direction, and from A to B, with respect to A, object is traveling to the left hand side direction. We are not bothered about whether the object has gone left side or right side, or we are not considering any sign convention. Simply we are measuring the distance. O to A distance is 60 kilometer, or O to A path length is 60 kilometer, and from A to B path length is how much? 25 kilometer. How much? How it is 25? Simply we will measure the intervals. How many intervals are there? 1, 2, 3, 4, 5. 5 intervals. 5 into 5, 25 kilometer. 25 kilometers. So 60 plus 25, it is 85 kilometer for the journey from O to A and back to B. Similarly, if I take from O to A and back to C, what is O to A distance? 60 kilometer. A to C distance, how much it is? So 35 kilometers. Simply 1, 2, 3, 4, 5, 6, 7. 7 intervals, 7 into 5, 35 kilometers. So total distance covered, or total path length for the journey from O to A and from A to C. So O to A it is 60 kilometer, from A to C it is 35 kilometer, equal to 95 kilometer, right? So object traveled, now I am considering the object has traveled from O to A, and from A it has came back to O again. In this journey, what is the total path length? What is the O to A distance? O to A distance is 60 kilometer, and from A to O it is how much? It is 120 kilometer. Here also you have not considered any sign convention. If I think from O to A, from O to A means object has traveled in the right hand side direction, and from A to O, if I'm saying with respect to A, object has traveled to the left hand side direction. But don't consider any direction, simply measure the path length. O to A path length is 60, A to O path length is 60 plus 60 plus 60, it is 120 kilometer. So this is for the distance concept. For the distance point of view you have studied. In next video, we will discuss about displacement. In For displacement, we will consider the sign convention. Distance is a scalar quantity and displacement is a vector quantity. So these things in detail we will discuss in coming video. Thank you. Hello everyone. Last video we have discussed about the term distance. In this video we will discuss more about displacement. As we know, distance and displacement are used to describe the overall motion of the object, but for the both terms, we will focus on initial position and the final position. Distance is a scalar quantity where only magnitude is important, but for the displacement, magnitude and direction both are important. Mainly for the displacement, we will focus on shortest distance. Whatever the shortest distance that we will measure, that is nothing but the displacement. We have to focus on initial position and the final position of the object. Mainly, while calculating the displacement, we will consider sign convention. So what is the sign convention? See, for this journey or for this travel of the object, I am considering when object travels towards the right hand side, it is positive, and when the object travels towards the left hand side, it is negative, right? So with this sign convention, we will go and we will study three different cases. First case, during motion from O to A and back to B. What is the distance traveled from O to A? O to A, it is 60 kilometer. It is positive as it is moving towards the, from O to A, it is moving towards the right hand side. If I consider from A to B, with respect to A, this journey, it is towards left hand side. So I have given it is negative sign. So O to A, it is positive 60 and A to B, it is negative 25. So if I add positive 60 minus 25, it is 35 kilometer. Second case, during the motion from O to A and back to C, O to A, how much is the distance? It is positive 60. And A to C, how much is the distance? It is 35 kilometer. But we have given it is negative. Why? It is moving towards the, with respect to A, if I am traveling from A to C, this distance is moving in a left hand side direction. Left hand side, it is negative sign. And if I measure the time intervals, 1 2 3 4 5 6 7, 7 into 5, 35. So positive 60 minus 35, it is 25 kilometer. So like this also I can calculate, or simply other ways. See, we have to focus on initial position and final position, and distance between the initial position and final position along a straight line we have to measure. So simply for first case, if I take journey from O to A and back to B, O is the initial position, B is the final position. Measure the distance between the initial position and the final position along straight line path. O initial position, B final position, O to B along straight line. How much is the distance? Measure the intervals 1, 2, 3, 4, 5, 6, 7. 7 into 5, how much it is? 35 kilometer. Like this also we can calculate. Consider about the second case. Journey from O to A back to C. O to A back to C. O is the initial position. C is the final position. Measure the distance between O and C along straight line. How much is the distance? Measure the time intervals 1, 2, 3, 4, 5. 5 into 5, how much it is? 25 kilometer. So I can say, without doing any sign convention or putting signs to these values, simply by focusing on initial position and final position and measuring the distance between the initial and final position along the straight line, we can come with the displacement values. Now the third case, if I consider, if the object travel from O to A and from A again, if it come back O, what is the displacement? Again, I will follow the sign convention. O to A, it is moving towards left hand side, and from A to O, it is moving towards left hand side. Sorry, O to A, it is moving towards right hand side, and A to O, it is moving towards left hand side. O to A, I will take it positive 60, and A to O, I will take it negative 60. So displacement will come. Displacement will come 0. But what about the distance corresponding to this displacement for the journey from O to A and back to O? Whether it is 0? No, it won't be 0, because there we are not assigning any sign to the values. Here simply we have measured the distance, or simply we have measured the path length. So displacement, here displacement can be 0, but distance corresponding to this displacement or this journey from O to A and back O, distance, it is a non-zero value. Displacement can be 0, but distance, it can't be 0. It is a non-zero value. So this is the comparison of a distance and displacement. Comparison of this distance further in coming videos we will discuss in detail. Thank you. Hello everyone. Last video we are discussing about distance and displacement. Some comparisons we have done. So in this video also, some few more comparison points we will go through. As we know, distance and displacement are used to describe the overall motion of the object and to locate its final position with respect to the initial position in a given time. So distance and displacement, these two terms are mainly we are using to describe the overall motion of the object. Mainly in distance and displacements, what we are doing is, there are two positions. One is initial position and other is a final position. So the location of the final position with respect to the initial position in a certain time or in a given time, we are defining it or we are describing it using the term distance and displacement. Whenever distance and displacement terms come, we have to give our focus on the object initial position, object final position. These are very important. So this is the object travel we have considered. A, B, C corresponding the positions of the object for the different instance we have considered. O is the initial position or origin we have considered. And now we want to compare distance and displacement for the few more points. As we know, distance is nothing but total path length on which object has traveled or total path length covered by the object. Distance is nothing but path length. We are not bothered about or we are not considering whether that path length is shortest or longest or which path we have chosen. We are just bothered about we have to start from initial position and we have to reach to the final position. By which path that object travels doesn't matter. So distance is nothing but the total path length. As distance is a scalar quantity, only magnitude is important. Distance, only the numerical value we will consider, not the direction of the motions we will consider for the distance. Right? For the distance, numerical value is more important or magnitude value has more importance and direction has no importance. We are not bothered about direction. So distance is nothing but total path length. And we know that distance is a scalar quantity. Only magnitude is required for distance. But same thing if I consider for displacement. For displacement, we are bothered about which path that object has chosen to travel, right? And that path has to be the shortest path. That distance has to be the shortest distance. The shortest path between the 2 points, we will call it as a displacement. The shortest distance measured from the initial to the final position of the object is known as a displacement. We are measuring the shortest distance between initial position and a final position. That distance, that shortest distance is nothing but the displacement. So displacement is nothing but the shortest distance measured. Again, displacement is a vector quantity. For displacement, we have to mention both magnitude also and direction also. And one of the most important thing about displacement is as we are measuring the shortest distance, that shortest distance is measured along straight line. This is very important point. So this is the comparison between the distance and displacement. Important thing what we have to remember is distance is a scalar quantity. Only magnitude is important. No direction required. We are not considering any sign convention for the distance. But for the displacement, we are bothered about the distance. Shortest distance we have to choose between the initial position and the final position. And displacement is a vector quantity where magnitude and direction both are important and both we should mention. Thank you. Hello everyone. Last video we have discussed about distance and displacement. In this video we will discuss some universal truths regarding with the distance and displacement. As we know, distance is equal to total path length. Total path length means there we are measuring the distance and we are not bothered about whether the distance is shortest or longest or any random path we can choose. Just we have to reach from initial, we have to start from the initial position and we have to reach to the final position. So what path we have chosen and what is the length of that path doesn't matter in case of a distance. But in case of a displacement, we are measuring the shortest distance. We are measuring the shortest distance between the initial position and the final position along the straight line. Remember, distance is a scalar quantity. There we are bothered about only the magnitude. But in case of displacement, we are bothered about magnitude and direction. For displacement, magnitude and direction both are very important. Now suppose I want to compare displacement and distance. I want to compare means suppose in between these two, I want to put a sign sign like less than or equal to, or greater than or equal to, or less than, greater than, or equal to. So what sign I should suppose to put here? What should I put? For that, see, we know the basic understanding. Displacement means shortest path, and distance means that path may be shortest and may be longest. It depends upon the object, or depend on that person, which path he or she or that object has chosen. Right? But displacement means shortest path, and distance means it is the just a path length, a total path length. That path length may be shortest or it may be longest. It may be. Right? So I want to put the sign. Simply again we will consider one journey. What earlier we have considered. O is the initial position and A, B, C are the positions for different instants. And the object has traveled in a straight line. Right. So suppose for this journey, now I want to reach to B and I want to start from O. So I want to travel from O to B. So for this journey, with two options I can go. First option, I can go, I can start from O, I can reach to B through C. That is the first option. And second option, I will go, I will start from O, I will go to A, and from A to B. Means O to B I will travel through A. That will be the second option. First option is O to B through C. That is the first option. And second option, O to B through E. That is the second option. Now, if I compare these two options or two paths, which path is the shortest path? Obvious, to reach to B, if I go through C or a distance, I will say OCB, that distance OCB will be the shortest. Now, this OCB, if you call it as a displacement or as a distance, meaning will be the same. So OCB is the shortest path. Consider it as a displacement or distance, it is the same. Now to reach B from O, OAB will be the longest path. OA will be the longest path. Now if I compare displacement and distance for this particular journey or what example we have taken. Now if I compare the shortest path and the longest path or displacement and the distance. So shortest path will be always equal to the shortest path. Shortest path OCB, consider it as a displacement or consider it as a distance, it will be the meaning will be the same. But now if I compare the shortest path with the longest path, shortest path OCB with the longest path OAB, is it possible that shortest path, is it greater than the longest path? Whether it is possible, shortest path is greater than the longest path. Whether it is possible, no. Shortest path will be always lesser than longest path, right? So here in between, I need to put the sign less than. I need to put the sign less than or equal to. Or equal to for what? Suppose the object has chosen the path which is the shortest path only. He himself has chosen the path which is the shortest only. In that case, displacement and distance, they can be equal, right? So distance and displacement and distance, if I compare, displacement will be always lesser than or equal to distance. Displacement will be always lesser than or equal to the distance d. Few more points are there, we will discuss in the next video. Thank you.